apologies that I don't speak French. So I hope that's going to be fine for today. Before I get started, so I would like to know how many of you have heard about NetApp before? Great. So let me start with the NetApp first. So what we do. So NetApp originally was a storage, we're the storage company, and we did like a lot of transformation. And now we are a data management, and also we are working with AI when it comes to creating optimization of pipelines and overall control plane around the whole AI, you can say, workflows and pipelines. We're going to be discussing that today. So before I jump into my presentation, so I would like to briefly introduce myself. So I'm a data scientist by profession and AI solutions architect working at NetApp. So I have worked in different industries like fintech, healthcare, and media mostly. So I would like to briefly go through this AI in banking. So what is happening right now in the market and where we are seeing right now the industry is adapting AI. I would like to know more from you folks. I would like to have that interactive session because today it feels like I'm back in home because I was working in different startups before joining NetApp. So I would like to have that environment here as well. AI in finance, so process automation, one of the examples where we can use AI, let's say in chatbots or automatically redirecting the mails in a huge chain where it belongs to. For example, if there is someone who is requesting for, let's say, some portfolio management. So who is responsible for that person, for that customer? So it should be automated. And then we have security. So here the security I'm talking about is fraud detection. So now the question is it helpful to detect fraud? Raise your hand who is with that, like fraud detection is helpful in some. And someone else who says that, okay, maybe or not, we need something else. Raise your hands, please. So everyone is with that we should do fraud detection. That's great. I'll get my money. I'll get my salary. Cool. So basically, before detecting fraud, so can't we focus on prevention? Because once fraud is detected, it's already done. You know what I mean? So why don't people talk about more fraud prevention? Any feedback from you guys? So we don't have enough data to do so. Because fraud detection, let's say we already have that data that if these scenarios happen, so that means we have some fraud over there. So this is simple detection. But what features constitute for that fraud to happen? So can we stop it, like, let's say, only 1 second, 2 seconds before, so we can stop that transaction before it happens? So these are some of the challenges, like we need data. And credit scoring. So before giving loan to someone, so we can do scoring based on certain parameters. So right now what's happening, if we don't talk about machine learning, deep learning, we use human intelligence, and that's great. But is there any proper rule behind that? How do we do that, like the proper scoring? We have different scoring mechanisms, but it's like human generated. Let's put in that format. But can machine automatically try to figure out if, for example, right now I'm earning, I don't know, $10 per day, and I'm asking for 1,000 euros, and shall I be getting that loan? Just by checking my previous history and not different factors like what's going to happen in 1 year, how much I'm going to get paid from my company, and all that stuff. So it's very difficult for one human to incorporate all that information. Now trading, I like it because it's talking about money. I like it. So for trading, you can use in different contexts. One, stock market. One more thing is portfolio management. So what do we mean by portfolio management? It's more tricky as compared to simple stock market. So in portfolio, you're thinking about different commodities behind that whole portfolio. How do we personalize that? Like for me, it's going to be different. So let's say I have a target I'm going to be saving by the end of my retirement, 60 million euros. Okay? So checking, and I'm earning $10 per day or 10 euros per day. So how do we do that? So AI can help us to, first of all, AI is going to kick me. So we try to frame that out. So how much I have to spend right now and how much I have to save. Ultimately, I can hit that goal. Also, where I need to invest. So whole portfolio management. And now it gets more interesting when we talk about hedge funding. So how many of us are here aware of hedge funding? Great. So before I switch, or before I talk a little more about hedge funding, how many of us here are from finance? Great. And how many of us here are, let's say, working in some uh, AI projects, machine learning, deep learning projects? That's great. That's great. So hedge fund, I guess I don't need to now explain what hedge funding is all about. So in hedge funding, we have to think about what underlying resources, or let's say securities, or other things that we have there is constituting for that fund. And how do we invest that later? So we had to think about calls, put, and other things associated. So ultimately, the goal is, can we try to predict what's going to happen just one day after, just 2 days after? Can we do that? So I guess this is the best example where we can use AI for trading, not just one stock. We are talking about different securities and other things associated. It gets complicated, multiple factors. And we have to think about risk. So what do I mean by risk? So one example is volatility. So what do we mean by volatility is something can happen and we're not sure, like different risk factors. One, if let's say some disaster, calamity is happening. We are not aware of that before. 9/11, one instance, stock market crashed down. So we cannot predict that. But can we somehow try to fit that using the previous history and try to bring that information in our models as well? And robo-advisory, the last example. We can go and talk about examples just 2-3 hours. So robo-advisory, chatbots, and other assistant systems that we don't need humans all the time over there. So we can reduce that time. So moving ahead, I'm going to talk about a little more trading. I like this topic. In 2018, there was a one paper published by JP Morgan. So I guess it was the first time that they used deep learning for hedge funding. They use reinforcement learning. So are we aware of reinforcement learning, all of us? So let me go one step before that. So there are different types of machine learning, deep learning. One is supervised. So supervised is simple. If we are trying to teach our model what is apple, what is orange, and all that stuff. So you should be having data. What is apple before you train it? So that's supervised learning. One image of apple, label it as apple. So that's up to us. Machine is going to learn. If we call apple orange, it's going to learn apple is orange. So that's called supervised. We already have that information. We already provide that information to our machine learning, deep learning. And then afterwards is unsupervised. What do I mean by unsupervised? So how many of us are using some online portal like e-commerce, Amazon, for example, or any other? So do you get some recommendations? It's not only personalized, but they're using some more information, like your age group, what age group you fall under, what gender you have, with location and all that stuff, and also what you bought previously. So now what you bought previously, leave that aside, focus on some general stuff, like your age and stuff. So this is called grouping, so you don't need any information. So model is going to learn. If your age group is 20 to 30, and there are like different folks around and you're male, probably you might buy this thing. I don't know, super fast racing bike or something that Amazon is not right now selling. So they will provide you information on the basis of that, so you don't need any information before. That's a supervised, like simple grouping, clustering. And finally, the reinforcement. So reinforcement is learning in real time. So if I put into picture, yeah. So this is what is happening. We are teaching machine to think like a trader. So trader is going to go through all the data that's provided to him, or what's happening in the real time, and try to figure out what is scenario right now that I should focus on more. What factors are influencing, or what factors are contributing towards that price stock. So it's going to learn in real time. So if you have some information before, and then machine is going to update that. If you are instructing machine that you should buy this stock, like right now the stock price is $10, and we have additional information like risk and other things, maybe tomorrow it's going to be 10 point something. So we have that information before from past 9 years. Afterwards, machine is going to automatically adjust that in the real time. What's going to be happening? Let's say if machine is saying that tomorrow the stock price is going to be $9, so don't buy it because you're going to lose money. And if that prediction was wrong, it was 11 euros. It will adjust automatically. It will learn in real time. So that's the reinforcement. So what do you think? Reinforcement, do we need some data for that? A few days back, just to share the one glimpse. A few days back, I was having a conversation with one of my colleagues from like research world. And we were having discussion like supervised, unsupervised, and reinforcement. And the question was, is there anything unsupervised? Like machines can learn automatically? Because I mentioned before, you have a categories: supervised, apple cat stuff, unsupervised, clustering, finally, reinforcement, where machines will learn as well. So the question was, is there anything unsupervised? That thing exists? That machine can learn automatically out of box? What do you think? I told you unsupervised is something like clustering. And now I'm telling you, is there something unsupervised? What do you think about it? I might feel stupid. So before clustering, you should know how many clusters you need. So you have to tell that information, or you have to feed that information to machine. That ultimately you're going to be having only, let's say, age groups. You should know that how many age groups are we talking about. That information you will feed to machine. So you have to give some information. So nothing exists without data. Now in reinforcement learning, if you want to train or you think that models are going to learn in future, first of all, you have to provide some information about that. Create that kind of scenarios for 5, 6, 7 years. Then in future, machine is going to learn. So we need data. So data should be there. Now, this was the kind of equation that we were talking about. So making it simple, what we are trying to do, we are trying to use present information of the stock and also the past, what happened to that stock in the past, considering some risk factors as well, and trying to predict what's going to be price at this time, let's say 10 days after. So that's what they tried to do. All good. It was learning in the real time as well. But the problem was that data availability was limited. So they used Eurostoxx data from 2011 to 2017 beginning, and total rows were only in thousands. And that information is not enough. And recently in 2019, one more paper from JP Morgan, what they did, other group. What they did, they used GAN, so generative adversarial networks. Means they created data, they synthesized data. So they have limited amount of data, why don't we create it? Using machine learning, deep learning only. And then in future, we can use that, fuse that data with the reinforcement approach. And the results were like this. So you see very close results, like the blue one is the real one, what happened in the market, and the yellow one is predicted one. So they were very close in this generation of results. And they don't need enough data because they are generating it. For generation, of course, you need something first to train it, and then afterwards, it generated more data out of box. Now, we talked about different applications. Still, for me, it's good in research. Let me tell you something. If you are investing millions of dollars, are you going to be willing to go with AI? No. Okay? Yes or no? Simple. Raise your hands, yes, if someone wants to try it out. Only 10 euros, come on, not millions. Great. Perfect. Now, let's say 1,000 euros. Only one hand. Two, great. Great, okay. So it's a bit complicated. Okay, sounds good. Now, let me tell you something. So today I'm coming from Munich, so I had to take flight. And in flight, I was thinking, like, do we know how flight works, like the mechanism? Because we are in air. And like millions of people fly each and every day. So do we know how it operates in air? Have you seen your pilot ever? Are you trusting pilot? For sure, exactly. So what is missing here? Do you think what I'm trying to do? So let me tell you one more thing. So the principle behind this airplane, how it flies, is basically Bernoulli's theorem, okay, Bernoulli's law. So simple, I don't want to go in physics. So if it's an airplane, so you have the air is flowing too fast above the wing as compared to what's happening below the wing. And due to that, it creates a thrust. That's called Bernoulli's law. Why it creates thrust? Newton's third law of motion. So why is there equal and opposite reaction? Do you know that? But you still trust. Anyone knows why there is equal and opposite reaction in Newton's law? But you trust. So it's a cultural change. So right now we are in that situation. So AI for me is now. But what is happening, we are trying to adapt to it. Definitely myself, I'm not going to invest millions still. But we are getting there. So some of the problems. First of all, before jumping to problems, to realize or to adapt these solutions in industry, so what we do. So we cannot train our models right away. So our data is messed up. Some information is missing. Let's say in finance data, you have information of customers. Let's say one customer location is missing, okay? some other customer date of birth is missing. Some other customer gender is missing. So you want to curate your data first. You want to make this data in such a form so that our machines will understand afterwards. It might be coming from different sources, from different locations. So that's the main job of data engineer over here, to create this data in such a format so that data scientists, here this green stuff, data scientists can use it. It should be properly available to data scientists. And data scientist, what he's gonna do, he's gonna select, let's say if we have 1 terabyte, 1 petabyte scale data, small amount of that data, 1%, 5%, 10%, to check everything is up and running, monitor it meanwhile, because if we talk about terabyte, petabyte scale data, we need some resources, and it takes time to train. So before jumping to that, we want to make sure that everything is up and running. So once that data scientist is confident enough that, okay, everything is as expected, so why don't we train it at scale, use different GPUs? You know, from 1, now I'm jumping to 10 to thousands of GPUs, depends. If my manager is happy with me and I can use, you know, he's gonna spend more money, then cool, I can use multiple GPUs. Now for me, because I'm coming from research and then jump to industry, in research, my job was finished here, like the JP Morgan stuff. I publish papers, all good, my job is done. Now how do we incubate that idea as an industry? Now the hard part begins, where I was like saying, my job is done, I'm leaving, okay, I'm bailing off. Training at scale comes with a lot of problems. So first problem, I'm a data scientist. I don't want to understand how I can make sure that different GPUs are gonna communicate in such a fashion so that we'll get maximum optimization of resources. Parallel programming, CUDA programming, all that stuff. Not my job. Now my data is located on different disks, separate across different locations. I don't care how I can fetch it with full optimization. Not my job. And usually what happens in industries, if we scale from 1 to 10 GPUs, for example, 1 GPU, my model is taking 12 hours or 10 hours. Now I got 10 GPUs, okay? My manager is telling me that cut that time by that amount of, I just gave you 10 GPUs, so now how much time it's gonna take? And if I say 1 hour, I'm doomed. You know why I cannot do that in 1 hour? My program here was meant to work in 1 GPU, okay? Now when I have different GPUs, they have to communicate with each other as well. I don't have to only send data, but meanwhile, while I'm training, they have to communicate with each other. And who's gonna make sure that it's a proper optimized one? Not only that, I need to create some kind of, some change in the code so that I can distribute. I can create distributed training platforms over there, or distributed training pipelines over there. And afterwards, still, I'm not gonna make it possible to get exactly like reduce it by 10 hours or 9 hours because now it's gonna take 1 hour. The reason is still some distribution is happening and some sync is happening. So I cannot say only 1 hour. And that's the biggest problem. And usually in industries, 60 to 70% of the GPUs like we are able to utilize, rest 40, 30% waste because of this optimization problem. We are not doing AI for kicks in industry. So we have to use these trained models in our applications, web applications, mobile phones, embedded applications. So someone has to take care of that, roll that model out there. Finally, machine learning is always probabilistic. We cannot say it's 100% that you're gonna get good results. So what do we need? We need to monitor it in real time and get that information back if we see something is wrong, feed that information back in this pipeline and start the whole pipeline again. Now one more problem. The guys who are working in AI, machine learning, deep learning in some manner, how many of you are using cloud? And how many of you are working on premises? Great stuff. So the cloud guys, why do you go with the cloud? Any reason? Scalability, good. Any more reasons? Cost, okay, scalability, cost. Any more reasons? Okay, security. So we have scalability, cost, and security. So on-premises, why do you go with on-premises? Confidentiality, anything else? Legacy, exactly. If you have option to go to cloud, let's say leave legacy, leave security, no constraints. Would you like to go to cloud? For example, hypothetical. Yes. So raise your hands from on-premises ones that can go to cloud afterwards. Whoa, that's great. Cloud fans. Okay, now tell me, cloud guys, if today you're using, let's say, Microsoft Cloud, okay, Azure, and then your manager is coming up with some great ideas, crazy ideas that can be only implemented in Google Cloud. How easy is that? Now what about on-premises? You're moving from one on-premises rig to other on-premises rig. Is this easy? The point that I'm making is cloud has its pros, on-premises has its pros. Cloud has its cons, on-premises is having its cons. So what do we need? So we're going to be having different sites. Sometimes we might be working on-premises, that is good for us, confidentiality, privacy. But sometimes we need scalability and on-go, like on-fly, like this. I need 10 GPUs right away, boom. Now I need only one, you got it. So we need that as well, okay? So we're going to be working on different sites, and how do we manage to get that done, to communicate with each other whenever I want? I'm moving from different cloud vendors, forget about it. For myself, it's a nightmare. I first of all learned Google, okay, then one day my customer is telling me that I'm migrating to AWS. Man, I'm not going to learn that CLI in one day. Give me some time. You are using S3, this APIs in Amazon, and now I'm using buckets, and I don't know. It's a nightmare. So you're going to be seeing this stuff. And at the same time, data engineer, let's say coming from the statistics background, more statistics. Data scientist is more this working around algorithms. And this guy, when we are rolling out models, coming from DevOps background. So he's not going to take care of Python if my data scientist is using Python, if my data engineer is using R. So somehow they had to work together. And here, we are losing a lot of information. We talk different languages. What do we do over there? One example that I'm going to show today is AI pipeline optimization. So how do we manage whole pipeline very efficiently? This is the usual scenario. So what I'm usually doing. So small training models, I'm going to use my laptop, because usually clusters, we had to wait, because other guys are also using. Or in cloud, my manager is not going to always give me credit cards to swipe over there. So I'm going to test on premises, let's say, for example, laptop or some small workstation. Everything is good. I switch to training rig if I have on premises. I don't have to pay anything. All good. Or sometimes if I want to create POCs very quickly, use cloud. And then later I can train that model on premises. What is problematic here? Different architectures. I might be having MacBook, but my on-premises rig is Ubuntu, cloud, I don't know, Red Hat. So one problem. Second problem, make sure that each and every package is available on each and every platform. So some of the problems that I'm quickly going through. So NetApp, we have NetApp Kubernetes services. So why don't we use data scientists these containers? The good thing that we can use containers and you don't have to be dependent on any platform. So data scientists, data engineers, why don't you use containers? Or if you're using, why are you using containers? So basically, when you talk about platforms like laptop, so you have hardware, you have operating system, and then on top of that, you use some application stack. Okay? Now, we are trying to virtualize whole stuff. So that means in my laptop, I can have same like Mac operating system and Ubuntu. So that's a virtualization. Now, we are not kind of creating different operating systems on top of architecture, but we are only creating small, you can say, bubble-like structures that is going to be supporting my application layer. It's going to share the same kernel, operating system kernel, Mac OS, for example, but it will, on top of that, use some different applications like Ubuntu, and use some like for the deep learning, use TensorFlow, and that's it. Once my job is done, it will be automatically terminated. So it's pretty fast and pretty quick as compared to VM that you're creating. The problem is for me was to learn Kubernetes. Container is good, I can create image, not an issue. But Kubernetes is a new giant for me. I don't want to mess up with it, because I'm being paid for creating algorithms and very quickly. I cannot learn new technology stack to make sure that I get the benefits. Like Kubernetes have scalability, you get this operability, that means across different platforms, but it's very difficult to learn first, and then integrate in the data science pipeline. So NetApp Kubernetes service is like 3 clicks. We don't need to learn what's happening, how Kubernetes is being set up. Now, as I mentioned, it's a bubble. Container is a bubble. Once your job is done, container is gone. If you have some data over there, it's gone as well. But in deep learning, machine learning, we don't want that. So we have a NetApp Trident open source plugin that's managing this. It's creating persistent volumes over there, and that's been attached to different NetApp, this Kubernetes services out there. Now, the problem is why I'm talking about Kubernetes and like all of a sudden from AI, machine learning, deep learning. You know, this guy is crazy. This is the reason. You can use different platforms. You're comfortable with TensorFlow, go ahead. You're comfortable with PyTorch, go ahead. Chainer, go ahead. So any other platform that you're comfortable with, MATLAB, I don't know. So still, I'm talking about fragments. So data engineer is still somewhere, data scientist is still somewhere, and AI ops guy is still somewhere. So how do we connect the dots? Simply, if I put it in words, When my data engineer is going to be done its like job, that means creation of the data, getting data sources from different locations and stuff, making data ready for me as a data scientist, then he will inform me, you know what, now data is ready, perform the training. So why don't we create some kind of trigger over there? So that's what is provided by the Kubeflow. Open source from Google, only works on top of Kubernetes, using all the features from Kubernetes. So that's why I was talking about Kubernetes. And Kubeflow is only meant for machine learning, deep learning solutions, like workflow management. We have different hyperparameter fine-tuning out of box. How does it look in reality? So this is what happens. Each and every component is independent, but logically they're connected. So what do I mean by independent? Is this. Each and every pipeline, that means training, you have its own image, container image. You have different parameters, location of the data set, this epochs and stuff like that. And so different, like my data engineer can use R. As a data scientist, I don't care. I need the results data set afterwards. And I can use Python. And this development guy, web application guy, can use Node.js and PHP, whatever he wants to use. So this is logically connected, but they can do whatever they want internally. No legacy issues and no this portability issues. So this is how it looks. So you can have train, serve, web UI. That means train your models, then serve that in your existing application, and spin up that web application and use that train model that you just did. And you don't have to be in queue. So once training is done, that resource is going to go back to the pool, like GPUs, so someone else can use it. And meanwhile, we are spinning up our web application and integrating that. It can be as complicated as this, because we don't see this simple workflow in real life. You might want to test. If some data information is missing, then, for example, do validation checks or do some testing. Finally, start the training. So it can be that complicated. How many of you are using versioning systems for your code? GitHub, GitLab? Is there anything for the machine learning? Let me tell you my experience 2 years, 3 years back. What I used to do, so we do a lot of pre-processing, everyone knows that, because we don't know, maybe if I do the average for the location, or like check the nearby location, tomorrow I might want to do average, running average to check that location, if that location was missing. So we're going to do a lot of experiments in pre-processing as well. So what I used to do, I used to create different folders. Raw data set, pre-process version 1, pre-process version 2, like that. And once I was having a project, the raw data set was around 1 terabyte, and at the end of project, it was 15 terabyte. Raw was still 1 terabyte, but I created different versions. And I don't want to delete. Maybe I use that in future, okay? And I used to create one kind of like Excel sheet. I use this data for particular model with these parameters. So that was my flow. Are you guys having that kind of flow? No one is stupid like me, I know that. So MLflow is one good example. MLflow is very much similar to Kubeflow as well. But the problem is, what happened if I delete some data? Accidentally, for example. Time travel, let's call it time travel. Can I do that? So there are some problems, like there are different versioning systems and some of them have problems. Now, NetApp is coming from exactly from the data management layer. So that's why we use Kubeflow on top of that and stuff. So for me, machine learning versioning is this. It's going to keep track of the best model. As I gave you example, the best model is gone accidentally, you know. So what's going to happen? Share with different data scientists, different data engineers. Now we are talking about team, 50, 100, 1,000 guys out there. And I need to share my results with those guys, and they need to share their code with me. How do we do that efficiently? ML model deployment, how do we roll it? Like software 1.0, we used to have proper CI/CD pipeline, continuous integration, continuous deployment mechanism. Can we get that in machine learning, deep learning? It's not only about code and parameters, it's also about data, what data you used. Finally, data provenance. If I had to go back in time travel, healthcare, finance, what data guys you used 1 year back for training this model? Can we do that? So data provenance is also, or data lineage is very important. One example I gave you, copy the data. I was doing it, copy the data, and use it again and again. GitHub, we cannot push all the data. GitHub is meant for code, it's not meant for your data. Now what we do, we call that snapshot. So we capture this in point in time. So you don't have to send your data anywhere. We create, you can say, capture it like pics, that's why it's called snapshot, take a snapshot, and you're not creating any copies. So what does that mean? Tomorrow if you add, let's say you have 1 terabyte data, and you're creating new pre-processing, and you're just adding one image. So it will only store that delta. And as a user, I don't need to take care of that. It's going to happen for me different directories. But internally, it's managing that automatically. So what we did, we integrated with the GitHub. So data scientists, okay, good with GitHub. We saw a lot of hands over here when I talk about GitHub, GitLab. So they should not learn anything new because it's not their job to first understand what's happening. So why don't we have some kind of mechanism that will integrate with the GitHub? So what we did, same. Usual flow is this. You write some code, you push that to your Git repository, whether locally or to some servers. But what we did, at the same time, we created this snapshot, and we linked that with our commit ID. Because commit ID is unique, it's a hash code. And we are not sending any data over there. Data is on premises again. Different data scientists, what they have to do, they have to pull that code, and automatically this data will be provided to that data scientist. Accidentally, if we remove something, it's like a time travel, so you can go back. Now, if you want to really delete that data, you have a GUI support. You have API support. Integrate with the application. 1 year afterwards, 2 years afterwards, you can delete that as well out of your logs. So basically, right now, we are seeing a migration from software 1.0, get the good things from software 1.0, and integrate with the software 2.0, that's AI, machine learning, deep learning, and IoT as well. So how do we do that? This was just a small gist around that. Thank you so much. May the AI be with you. And this is some of the resources. If you later want to go through it, some of the blogs and some of the documents over here. Thank you so much. Have a nice evening.